So the slope is just a number that tells us how steep the line is. So the bigger number is, that represents we must be talking about a steeper line. So looking at problem number 1, what did you guys put? Which of these two, let's see, if one of these lines has a slope of 1 and the other one has a slope of 3, and those are the only choices, okay? Look at line A. Do you think that's the one that has a slope of 1 or a slope of 3?
3. 1.
You better show me on your fingers real quick. We're looking at line A. One of these has a slope of 1. One of them has a slope of 3. Go ahead and show me on your fingers which the slope of line A. Do you hold up either a 1 or a 3 right now for line A? Keep them up for 1 second. You don't, no sabes? Okay. All right, put him down. Put him down.
So it's 3.
Okay, line A was steeper, so line A must be the one that has slope 3, and line B must be the one that has slope 1.
How do you write slope? Is that M?
Yeah, M. They use M for slope for some reason.
Yes.
Right. The only options were 1 and 3, so it's kind of a matching situation. So knowing that those are the only two options and these are the two lines, A is the steeper line, so it must have the bigger number for slope. Okay. Now, slopes can be positive or negative. When you are deciding if the slope is positive or negative, always look at it from left to right, like the way we read a book, from left to right. If it's going uphill from left to right, that's going to be positive. Okay? So with you guys looking at me, would this, my arms, would this be a positive or a negative slope? That's a positive slope, okay? Because from left to right, that's going uphill. A negative slope would look like that, from left to right, okay? Okay, so looking at number 2. So what about A? Everybody say positive or negative out loud right now.
Negative.
A is negative. I'm just going to put neg. A is negative. From left to right, it's going downhill. What about B, everybody?
Positive.
B is positive. Again, from left to right, it's going uphill. What about C?
Positive.
All right, I didn't hear enough people that time, so.
Positive.
All right, for the next one, we're going to do it on our fingers up. C was positive. For D, give me a thumbs up for positive, thumbs down for negative, real quick.
Which one?
We're doing D. D. Okay, put him down, put him down. Almost everybody did have negative, because from left to right, D is downhill. Any questions so far? Will you close the door for me real quick? Now, slopes can also be 0 or undefined. Okay, there are other options besides just positive or negative. You can have a 0 slope, and some slopes are undefined. Slopes that are horizontal are 0. Horizontal slopes are 0. And just in case you need this vocabulary, horizontal is like the horizon. Okay? So this would be, okay, that line I just drew, that's a horizontal line. It would have a slope of 0. Of course, a vertical line would look like this. All right, that second line I just drew, maybe I'll do colors. The red line I just drew is a vertical line. It would have a slope that is undefined, or you could say no slope. Okay, so you just have to memorize that. So horizontal is going to have your slope of 0. And vertical lines are going to be undefined or no slope. Okay. So classify each slope as positive, negative, 0, or undefined. Okay. All right, so what about A? We'll go back to trying it verbally again, but I need everybody to respond. So look at A, positive, negative, 0, or undefined?
0.
A has slope 0. It's horizontal, which means it has slope 0.
I still would be right with horizontal because I put like horizontal and like positive, meaning rise and fall.
Well, it says classify each slope as positive, negative, 0, or undefined. So you have to follow the directions and use the options that you're given. Only water. Okay? So what about B? Everybody say it out loud right now.
Negative.
B is negative because of the way that's downhill from left to right. And that's negative. All right, what about C, everybody?
Vertical.
No slope.
For C, because I'm asking about the slope, you can either say undefined or you can say no slope. Okay, if I ask you about the slope and you say vertical, that's wrong. Okay, vertical is not a slope. Okay, you have to tell me that this line, this vertical line has a slope that's undefined or no slope. And what about D?
Positive.
D has a slope that is positive because it's uphill from left to right. Okay, any questions so far? Okay, so now, so that was the general concept. So far we've learned or remembered that the slope tells you how steep a line is. The steeper the line, that's a slope. If this is slope 1, slope 2, slope 3, the bigger the number gets, the steeper the line gets. We learned that. And we just learned that a slope can either be, okay, from your perspective, it can either be positive
Or negative.
or it could be negative. Show me with your arms what a 0 slope would look like. Everybody show me with your arms what a 0 slope would look like. All right, I saw the people that were looking around for everybody else. All right, good job. 0 slope looks like this. Show me with your arms what a undefined slope would look like. Okay? This is what an undefined slope would look like. Thank you. All right, everybody put your arms down. Okay, so that's what we've learned so far. All right, now we're going to add the numbers into it. So now we're getting back to what you probably learned in middle school and stuff. Rise over run. The slope is the vertical change divided by the horizontal change. Rise over run. Okay, so hold that picture in the back of your mind. Rise over run. So looking at number 4, if I want to calculate the slope, okay? Now, Christian, first of all, is this a positive slope or a negative slope? Okay, see what I'm doing with Chris? I want everybody to ask yourself, before you even calculate anything, I want you to decide if it's positive or negative or 0 or undefined. So Chris said this is going to be a negative slope. So whatever else we do, we know it's going to be a negative answer. Okay, so now let's do this fraction for me, Chris. What over what? Just like set it up for me. Let's show our steps.
4 over 2.
Right, slope is rise over run. So it's going to be negative 4 over 2. Obviously, I'm not going to leave it like that, am I? What am I going to put? What's 4 divided by 2? 2, okay? So my final answer would be negative 2. Okay, that's the slope of A is negative 2. Any questions right there? Okay, Tiger. Look at B. Is this going to be a positive, negative? What kind of slope am I talking about? All right, this is a positive slope. Now go ahead and set it up for me. Starts off as 3 over 6, because that's rise over run. How does it reduce? And that reduces down to 1/2. Okay? So B should be a slope of 1/2. Any questions so far? Bryant. I'm in a question about this right here. On topic. All right, let's move on to C. Okay, looking at C, Daniel. Is this a positive or a negative slope, Daniel? This is definitely a positive slope because the way it's going uphill. Agreed? Set it up for me, Daniel. Right, this is going to be 3 over 2 because that's my rise over run. Is there anything else I can do with this? But it doesn't. Like 3 over 2, nothing divides into 3 and 2, so let's just leave it like that. Notice I'm not making decimals, so please don't give me any decimals. Just leave it as a fraction, just like this. I got you. Tyler, talk to me about the slope for D. It's going to be negative because of the way it's downhill. Now set it up for me. It's going to be negative 4 over 4. Shall I leave it like that? It simplifies to negative 1. So I'm hoping you guys all did this before, and now you're just watching me give you the answers. Okay? I'm hoping you did this in the break before we started. All right, is everybody getting these answers right? Is he good? Okay. All right. All right. This is the foundation, so it's important that I not lose anybody. Okay? Foundation. Exactly. All right, so moving on to number 5. So, Jill, we need to calculate the slope of number 5. Can you help me? Do you have any thoughts on that?
Yeah, it's going to be positive.
It's going to definitely be positive, so I like how that's the first thing you're thinking of is negative or positive. Keep thinking that way.
10, and then it'd be 3 over 4.
Okay, see how she's just looking at the graph. So you should be able to get the numbers yourself off the graph. If you look at the points that I sort of emphasized to you, if you focus your eyes on those endpoints, then this is the rise, is the vertical change, right? That rise, so there's like a rise of 3. And I hear Jill saying that this is the run, rise over run, and there's a run of 4. So that's why she said the slope will be 3/4, and it's positive, so we just put 3/4. Jet. That's 1. Okay, so looking at number 6. Now look, here's something I need to emphasize to you. Here's one source of mistakes that kids make. A lot of times you guys will just glance at the squares and you'll just count squares. So on this picture, if you were counting the squares, if you ignore the numbers, what would the slope appear to be? Like, what's the rise? If you ignore the numbers, what's the rise? 2. It looks like the rise is 2 because it has these 2 squares right here. What does the run seem to be?
3.
Right, just counting squares, it would look like it was 3. So a common mistake would be to go, oh, this is going to be slope 2 over 3. But that's going to wind up being wrong. Why? Why is this wrong? Why?
Because the numbers.
You have to use the numbers. You cannot ignore the numbers and just go for the squares. The numbers tell a story. So, because of that, in terms of rise and run, did I pick on Jill yet? Jill. Oh, yeah, no, we talked, didn't we? We did number 5. All right, Andrew. All right, look at number 6 and talk to me about the rise. What's the real rise of number 6? The true rise is 4. Okay? Using the numbers, we see that this is a height of 4. So the rise is 4. Wait, I forgot to do what Jill always does. Right at the beginning, I'm supposed to ask myself, is this a positive or negative slope? It's clearly negative. Can everybody see that? Just right from the beginning, it's downhill, it's negative. Just get that out of the way. So whatever else we have, we're going to have a big old negative sign in front. Okay? So what's the run, brother? And the run is 15. Forget about the 3. The run is 15. So we have 4, negative 4 over 15. Can that be reduced? No. So the slope, instead of being negative 2/3, we see it's actually negative 4 over 15. So again, use the numbers. Use the numbers, not just the squares. Okay? Raise your hand if you already have an answer for number 7 ready to go. Okay, that was only a couple people. I'm going to pause it. Well, I thought you were saying it for me. We're doing a quiet mode. And see, I thought we had a thing going. Okay. So, blurt out the answer to number 7, everybody.
5.
Okay. The answer should be 5. So if you did not get 5, then watch carefully to understand what you did wrong. But walking around, most people had 5. See, I think, okay, so I'm at Haley. Okay, just give me the rise. Just give me the rise.
The rise is going to be 10.
Well, the rise is how far up it goes. So how, like looking at this dot, how high up is it? Yes, okay. So as we talk about rise over run, okay, as I get ready to do that. First of all, Haley, is this overall going to be a positive or a negative slope? It's going to be positive, Haley said, because why?
Because the way the line is.
Yeah, because it's rising. From left to right, it's going uphill, it's rising, so it's definitely going to be a positive slope. Check. I hear Haley saying that the rise is 150. Okay, I always try to make a triangle out of it, so if I sort of dropped a line straight down like that, there's my triangle. So there's my rise of 150, like right there. Okay, so it's 150 high. Now, what's the run, Haley?
The run would be 30.
Yeah, the run is 30, because the run is the horizontal change. So it's like from there to there, so the run is 30.
Okay. Then you divide 3.
Yes, ma'am. So it's just a matter of 150 divided by 30. Okay, with all these zeros, I mean, you could use your mental math, and canceling out those zeros is like dividing everything by 10. So it would be the same as 15 divided by 3, which we all know is 5 in our heads. Okay, so that's why the slope was 5. Any questions on number 7? Okay. Now, getting to some calculations. If you have the coordinates, you can calculate the slope. If you have the endpoints, you can calculate the slope by doing y minus y divided by x minus x. I mean, think about it. If I didn't have a picture, remember the rise. The rise is the difference in the y values. It's the change in height. So it makes sense that you should be able to get that vertical change by subtracting the bigger y minus the smaller y. Okay? And the run is the horizontal change. So it makes sense that I should be able to find the run by subtracting the x's from each other to get that horizontal change. Okay? So look at number 8. If I want to calculate the slope of number 8, okay? Now I want to do the rise up there, but now I've got numbers. So I'm going to do y minus y. Okay, sure, I'll do y2 minus y1. That's my rise over x2 minus x1. Okay, so, Ashley, help me. What will I put in the top?
7 minus 3.
So if I do my y minus y, does everyone understand that that is 7 minus 3?
Yes.
Okay, did I lose anybody just then? Over what? Keep going, Ashley.
4 minus 2.
Over 4 minus 2, because that's x minus x. Okay, and we just simplify that and we get it. So 7 minus 3 is 4.
Over 2.
Which is?
2.
So the final answer would just be 2. So the slope is 2. Simple, but you have to know that formula. I mean, it's a simple little formula, but you have to know it. Slope is y minus y over x minus x. You memorize it if you have to. Okay, so number 9. Chase, help me out. Talk to me.
2 minus 5. I thought that was 2.
Yes, okay. Let me point out something like Chase was just saying. See how he said 2 minus 5 or 5 minus 2? It really doesn't matter which order you do it in, as long as you do it the same way for the top and the bottom. So if I do 5 minus 2, for example, then I must do what for the bottom? Then I must do 4 minus negative 1. But just to be clear, I could have done 2 minus 5. But if I do 2 minus 5, then I must do what in the bottom? Negative 1 minus 4. You have to do it the same way both times, but it doesn't really matter. Okay? So 5 minus 2, what's that?
3.
That's 3. Now, how do I handle 4 minus negative 1? Yes, please understand that when you subtract a negative, and this is a common mistake, so everybody focus. When you subtract a negative, it's just like addition. 4 minus negative 1 is the same thing as 4 plus 1. So I usually will skip the minus and negative, and as soon as I see that the second number is negative, I do addition immediately. I'm going to encourage you to do the same thing. So when I see 4 minus, oh, the second one's negative, just add. Go straight to addition. So this will be 5. So for number 9, the slope should be 3/5. Any questions on that? Okay. Now, when we were developing the basic concept, we said that the slope could sometimes be 0 or undefined. So I need, or no slope. I need to show you what that looks like in these calculations. How will we know if it's a 0? How will I know if it's undefined? What will that look like? Well, here it is, and just spell it out for you. If you get something over 0, I'm hoping back in elementary school they drilled into your brain. You cannot divide by 0. You can't take something and then split it up into 0 parts, because that's how division works. If you divide by 3, you make 3 groups. If you divide by 0, that means you're making no groups at all. You can't take a bunch of students and divide them up and have no groups. So you can't divide by 0. So if you see 0 in the denominator, that's impossible. So that's going to be the one that's undefined, okay, or no slope. If you have 0 in the numerator, that still makes sense. If I have no Halloween candy, and I share my Halloween candy equally with each of you, how much Halloween candy will each of you get?
0.
Each of you will get an equal 0. So you can, in your mind, you can think of yourself as sharing nothing. So that works. It just gives you 0. So 0 in the numerator is just going to be 0. 0 in the denominator, that's going to be undefined. Okay? So, something else I want you to have in the back of your mind. If you do get 0 in the denominator, I want you to make the connection and go, oh, if I were to graph this, this must be a vertical line, because a vertical line would have undefined slope. If you get 0 in the numerator, I want you to think this must be a horizontal line, because that's the kind of line that has a 0 slope. Yes, Derek. One more thing. Do not leave your answer with 0 in a fraction. I emphasize this every year, but every year somebody will do this. Like on a quiz, like our next quiz will be 1 week from today, next Friday. If I ask you for the slope, you may not give me, for example, 5 over 0. Okay? Because you're not showing me that you understand. Instead of 5 over 0, what should you say?
No slope.
Right. You should, instead of saying that, you should either say no slope or you should say undefined. Okay? Please, please don't do this. Every year on this unit, I have kids leaving their answer as like 0 over 5. Okay? I'm not giving you credit for that. Because some kids will have 0 over 5, and then they'll put undefined. And they're going to get it wrong. So I'm not going to give it to you just for leaving it like that. You have to show me that you know that this, what should you put instead of 0 over 5?
0.
You've got to show me that you know that that's just 0. Never leave 0 in the fraction. Yes, Jet. All right. So, looking around the room, tell me what you guys got for number 10. Just blurt it out.
0.
Number 10 was 0. What about number 11?
No slope.
Either undefined or no slope. Okay, I'm going to go through it obviously though. So remember the slope. Remember the formula for slope. We're supposed to do y minus y over x minus x. Y minus y over x minus x. Because that's rise over run. Okay, so for number 10, when we go to do the slope. So say if I'm going to do negative 2, I'm looking at the second negative 2. I'm going to do negative 2 minus negative 2. But the second I see that the second number is negative, I immediately switch it to a plus. I think negative 2 plus 2 instead. Okay? And then I'm going to do 3 minus 1 for my x minus x. So that's going to give me 0 over 2. Now, depending on how you did it, you might have 0 over negative 2. That doesn't matter at all. That's just as good. Because either way, we're going to get 0 for our final answer. And then for this one, y minus y. So that would be 5. Okay, and I see that negative 1 coming. 5 minus negative 1. As soon as I see that the second number is negative, I immediately put plus. Just go straight to the plus when the second number is negative, okay? So 5 plus 1 because of the minus negative. And then, of course, 2 minus 2 down there. So that should give me 6 over 0. Depending on how you did it, you might have had negative 6 over 0. Also fine. Yes. Devon. Hold on. Okay. Now the midpoint. This is the last concept we need to get down today. Midpoint. You know instinctively what a midpoint is. When we learned it in the last unit, just in your own words, what is a midpoint? Go ahead, Matt.
The midpoint is the, I would say, middle of a line or bisector.
Yeah, if you have a segment, it's going to be the middle of the segment. I mean, it is what it says. Midpoint. It's the point at the middle. That's what it is. Okay? You get it. It's just a matter of if I have coordinates, if I have these numbers for endpoints, how do I calculate it? That's all I'm trying to teach you. Now, I want you to have this word in your mind. When you think midpoint, I want you to think the word average. Average. Okay? Because this is a concept that you already know. If you get an 83 on one test, and you get a 97 on another test, how do you find the average of your two test grades? You add them up and divide by 2. That's how you do the average. Well, look, when we're finding the midpoint of 2 points, all we're really doing is finding the average of the x values and the average of the y values. So we're going to take the x values, we're going to add them up and divide by 2, just like those test grades. We're going to take the y values. We're going to add them up and divide by 2. We're just doing the average. That's it. If you think of it as average, it won't be another formula for you to memorize. You'll already know it. Okay? So, if I want to find the midpoint for problem number 12, for the x value, I'm going to find the average of these x values. So I'm going to do negative 3 plus 2 divided by 2. All right, because these are my x values, are my negative 3 and my 2. I'm doing the average of them. Okay? All right. Scott. How am I going to do my y values?
I'm going to add it in.
Add what and divide by 2?
Like 5 and 2.
Yeah. So for the y values, I could do negative 2 plus 5 divided by 2. I'm just going to do the average of the y values, and that should be the y value of the midpoint. Okay? So that's going to give me, okay, so negative 3 plus 2, that's negative 1. Okay, so the x value of my midpoint is negative 1/2. Negative 2 plus 5, that's 3. Okay, so please go ahead and just leave it as a fraction for right now. But that, these are the coordinates of the midpoint.
Boy, hold on, you said 0.5 is 1/2.
I didn't say that, but that's true. Okay? So this is how I would want you to find your answer. But if we wanted to graph this, we would have to use decimals. I put this graph paper here because I want you to make a connection between the visual way we learned it last week and the numerical thing that we're doing now. So in general, I'm not going to give you a graph, but just once I want to graph it and verify that it's doing what we say it's going to do. So if you didn't already do it, please graph this with me right now. Okay, let's graph these endpoints. So look at this point, -3, -2. If I want to graph that, of course, I'm going to go left 3 and down 2, because -3, 2. So -3, -2. So that first endpoint would be right here where I just put that blue dot. Now graph the other endpoint with me, 2, 5. Of course, that means I'm going to go right 2 and up 5. So I'm going to go right 2 and then up 3, 4, 5. So the 2 blue dots I just put on the screen, those would be the endpoints of this segment. Go ahead and connect the dots to show this segment. Okay, so there's my segment.
Mr. Burton, no.
Why'd you go five?
What? Mr. Burton, you grabbed her.
Okay, like Jet was saying, let's turn these into decimals just so we can see. So this would be the same thing as negative what? How do I write -1/2 as a decimal?
Like 0.5.
Yeah, this would be like -0.5. What about 3/2? That's like 1.5. Okay, so -0.5, that's left half of a square. Okay, so I could go to, if I go to the left half of a square, and then I'm going to go up 1.5. That's up 1 square and a half. So I'm going to go left half of a square, and then I'm going to go up 1 square and a half. That would put me right here. Okay, that red dot represents our calculations. Does that appear to be in the middle of the segment?
Yes, sir. I have a question.
It does appear to be the middle. So I'm hoping you can see how our visual midpoint that we learned seems to match with the numbers that we're calculating. Ready? So for number 13, again, we'll do the average of the y's. So this should be like 7. I mean the average of the x's. What was I don't know what that was. We'll do the average of the x's and then the average of the y's. So this will be 2 plus 2 divided by 2, average of the x's. And then the average of the y's would be 7 plus -5 divided by 2. Okay, so that's going to give me 4/2, which is just 2. Maybe I should show it. So that's going to give me 4/2, and that's going to give me 2/2. So that's going to give me 2, 1. All right, did everyone get 2, 1 for number 13?
Yeah.
Okay. All right. Now the last problem. Okay, so here's a model of 2 endpoints and a midpoint. And we want to explore the relationships between them. Our essential question is, how do you find the missing endpoint if you are given one endpoint and the midpoint? Alright, so let's say if I give you the first endpoint and I give you the midpoint. So we're talking about a situation like this. I've given you the first endpoint and I've given you the midpoint, and then we're supposed to find the other endpoint. But really quickly, before I dive in and show you how to find the missing endpoint, let me just briefly review with you how we find the midpoint if we know both endpoints. I think if I do both problems the same way, one right after the other, you'll see all the connections and it'll look like common sense to you. So before we do this problem, here's an example, a quick example of how we used to do it when we knew both endpoints. Point is 2, 3. The other endpoint is 6, 11. I've tried to emphasize that finding the midpoint is all about finding the average. If we find the average of the x values, that's going to give us the x value of the midpoint. If we find the average of the y values, we will find the y value of the midpoint. And how do you find the average of two things? You add them up and divide by 2. So that's what we do. So basically it looks like this. If we had, we're going to basically do two separate calculations. One calculation will be for the x values, and another calculation will be for the y values. Okay, so in this case, for the x values, we would do this. So if we do the average of the x values, then we are talking about 2 and 6 are the x values. So if we add them up and divide by 2, obviously 2 plus 6 is 8. So that's going to be 8 over 2, which is 4. So far, that gives us the x value of the midpoint is 4. Now we're going to do the same thing with the y values. Okay, but the y values are 3 and 11. So if we do our 3 plus 11 divided by 2. So that's going to be 14 divided by 2. Which of course is 7. So that gives us the y value of our midpoint. Okay, so that's how we would find that the midpoint is 4, 7. So I think we all understand that. That's, if you have the coordinates of the endpoints given, this is how you would find the midpoint. All right, so the next step, because look, our goal is going to be, what if I give you one endpoint and the midpoint? How do you find the other endpoint? That's our goal. Okay, so again, our essential question is, how do you find the missing endpoint if you are given one endpoint and the midpoint? So a way of helping you understand that is by starting with just all variables. So just like before, when we found the midpoint by doing the average of the two endpoints, and we set up two equations to calculate the numbers that made up the midpoint. Let's go ahead and set up those two equations right now. Let's make an x value equation and let's make a y value equation. So what is the x value equation that I could make? Imagine that these were all real numbers, and I'm trying to find the midpoint. What would I do? Okay, so just like we did before, we're going to take the average of the x values. So we're going to add up the x values, divide by 2, and see what we get. And we'll do the same thing for the y values. We're going to add up those y values, divide by 2, and see what we get. So for the x values, what are my two x values right now? Alright, I've got A and E. Alright, those would be the x values I want to take the average of. So I would do A plus E divided by 2. And that should give me the midpoint x value. Well, we already have a variable for that. So that should equal C. Okay, so the average of the x's should give me the x value of the midpoint, which in this case is c. So what am I going to write here for the y values? What am I going to put here and here and here? Go ahead and say it out loud if you can. Okay, we're going to do the average of the y values. That means since the y values are b and f, okay, I mean, does everybody understand that all of these points are in the form x comma y? So the x's are first and the y's are second. So the y values are b and f. So I'm going to do b plus f divided by 2. And what should that equal? Well, that should equal d, because that should give me the y value of the midpoint. Okay, so we have these two equations that we could set up anytime we are talking about the midpoint. Okay, so hold that in your brain. So now let's go ahead and get to our essential question of how do we find a missing endpoint if we're given one endpoint and the midpoint. Okay, so let's modify this so that we're given one endpoint and then the midpoint. Okay, so I'm going to erase these two. I'm going to leave this as variables, and okay, so let's use this as an example. Find the other endpoint if 1 comma 4 is the midpoint. Okay, so the midpoint is 1 comma 4, and negative 5 comma 8 is the first endpoint. Okay, so negative 5 comma 8. Alright, negative 5 comma 8 is the first endpoint. So we're given an endpoint and the midpoint, and our goal is to find the other endpoint. Okay, so I want you to set up the same two equations that we set up before when it was all variables. Alright, remember, when we are trying to find the midpoint, we take the average of the two endpoints. It's got to be the average of the endpoints, and that should equal the midpoint. So again, the endpoints, if I'm talking about the x values, let's do the x values first. The endpoints, the x values are negative 5 and e. So I need to take the average of negative 5 and e. So we used to have a here, so let's just replace that. So we take that out, and so now that's negative 5. Okay, so the average of negative 5 and e, so add those up and divide by 2. That should equal the x value of the midpoint, which we had c before. Okay, but now we have a value of 1. Okay, so x value plus x value from the endpoints, divide by 2, that should equal the x value of the midpoint. So we have that equation. Do the same thing for the y values. Okay, so I'm going to get rid of my b and my d. I still have the f. So the y values are 8 and f, and then that should equal 4. So if I do a y value of 8 plus a y value of f, find the average, so divide by 2, that should equal what? That should equal 4. Okay, the average of the two endpoint y values should equal the midpoint y value. So we've got these two equations. Now, do you see our variables are e and f? So if we solve this for e, that's going to be the value of the x value of our endpoint. And if we solve this equation for f, that'll give us the y value of our other endpoint. So that's what we're going to do. Let's just solve this equation. Okay, so the thing to do would be, let's see, I think I'll use green. You see this denominator of 2. So the easiest thing to do is to multiply by the denominator. So I'm going to multiply both sides of this equation by 2. Okay? And I might as well do this equation at the same time. So if I'm going to also multiply by 2 on both sides of this equation. Alright? That way these 2's will cancel each other out. And that's just going to leave me with, alright, I've got negative 5 plus e equals 2. Okay, and on this one, these 2's cancel each other out, and that's going to leave me with 8 plus f equals 8. Okay, so if I want to solve this for e, I'm going to go ahead and add 5 to both sides. Plus 5 plus 5. So that's going to give me e equals 7. And on this side, I'm going to subtract 8 from both sides. So minus 8 minus 8. And that's going to give me f equals 0. So that means, you know, translating both of these values into this. Okay, that means this missing endpoint is the point 7, 0. So that is what we were trying to find. You know, of course, you could check your answer. You know, if you weren't sure, you could go ahead and check your answer by seeing, if I take the average of these x values, do I really get 1? If I take the average of these y values, do I really get 4? Okay, so maybe I should do that off to the side real quick. Check. Okay, let's do the x values. Negative 5 plus 7. So I'm taking the average of the x values divided by 2. What does that make? Well, negative 5 plus 7, that's 2. So that's 2 over 2. So that does equal 1. Okay, which is what we had. So far so good. The x values check out. Let's check our work on the y values. 8 and 0. So if I do 8 plus 0 divided by 2, well, that would just be 8 divided by 2, and that would be 4. Okay, a y value of 4. And that would give us the correct y value. So it checks out. So that is how you find the missing endpoint if you're given one endpoint and the midpoint. Set up two equations. Set up an x value equation and set up a y value equation. And your missing x value should be right here, like the e, and your missing y value should be here, like this f. And then you just solve, and you'll find your endpoint.